There's not much more to do on this, guys. So let's take a look at what it means to actually begin to analyze this. And I have some more analysis tools to introduce maybe tomorrow or maybe not. We'll see about when we can get into laser cut. But the one that I just want to show you now is how do you actually create a graphic color scalar relationship across these things so that you can read a model in an analytic fashion. Okay, so right now it's going to be very baseline. We're going to do it as, basically, the whole domain of color is just going to be mapped similar to the way that we've done the extrusions. So one of the things that you need to be aware of is that in order to apply color in Grasshopper, you unfortunately need to make it a mesh, or at least mesh is the most direct way of doing it. So it usually happens at the end of a definition, right? So, or wherever one of your thoughts stops or can, digress into an actual analysis. But it looks something like this. What we need to do is go under Mesh and Primitive, and we're going to do this one called Mesh Colors. Mesh Colors is going to ask you for the base mesh, which essentially is the triangulated form, just the triangulated geometrical form, basically. And the actual color. Okay, so we'll define what that color is a couple different ways. We're going to use a graphic slider. So the other thing that we have to do is convert the geometry, or in this case it's a brep, I believe. Yeah, it's a brep. So we need to convert the brep, which functions like a surface in Rhino, to a mesh, which is triangulated. So we're going to go up under Mesh and Primitive, Construct Mesh. I'm sorry, no, not that. It's sorry, it's under Utility, Mesh brep, I think. Yeah. Mesh Utility, and this one is under Mesh Primitive. So when we construct, or when we insert the brep into the brep input for mesh, you'll see that it actually converted it. So let me hide this one so we see the latest geometry. And it looks pretty much the same, except you don't really have all of the lines showing. It shows a little bit smoother, kind of like Qbert. You guys remember the game Qbert? Anybody? No? Does anybody remember the game Qbert?
Qbert?
Qbert. All right, well, we'll have a discussion about this in a bit. But anyway, mesh brep then gets plugged into mesh colors, like that. And you'll see that it started coloring this thing up, but right now it kind of just looks like it's got the same gradient on all of them. That's because it can't differentiate where to put the colors. So, now I'm forgetting where my components are. Ah, yes. So under params and input, we have used the image sampler where we dropped in images. I don't think we used the color swatch yet, have we? Yeah, we'll use that later. But the gradient here is interesting because when you drop the gradient in, it kind of gives you this big slider. For those of you who have used Photoshop, you know how gradients behave. You give it a beginning color, you give it intermediate colors to transition or blend to, and then you give it a termination color. In this case, it actually has a couple of different inputs. So it has the lower limit of the gradient range, which means the items that are at the lower limit of your list, right? So this is kind of a domain-based approach. will get a certain color, right? It'll be colored closer to that side of the gradient. And then you have the upper limit, right? So the upper limit of the domain will get colored toward the end of the gradient. And T is based off of the distance, I believe, from the closest point, if I'm not mistaken. Okay, so it's basically the position, if you call it. Like where is this thing so that I can test it. So let me get this stuff out of the way, because we're going to kind of pull off of that a little bit. But essentially the what we need to do is tell it what the lower limit and the upper limit are, so that it can colorize appropriately. So we can basically take the boundary, like that. So we can basically just take the boundary, right, that gives us our domain, and we can deconstruct it. So we go under Math and Domain and Deconstruct Domain, and plug that in. And what that gives us, again, is the start of the domain, or in this case, the lower limit, and the end of the domain, or in this case, the upper limit. So S goes into O, and E goes into L. I'm sorry, 1. And then the last part, T, is the... Let me move this so that you can see what the connection is. T is going to be the parameter along the gradient range, which in this case is going to be our distance. So I plug the distance into T, and it goes gray, which means that it's active. So when that gets plugged into mesh colors, it's starting to make a change, right? It's not fully there yet. Whoops, I mean to do that. Another thing to note about this is that there are presets in this top left corner. If you double click that, where is it? Do you right click? There you go. Yeah, you right click it and you go to presets, and you can pick some of these basic ones here. So I kind of like this one as an analysis tool to start off with. But the other thing that's kind of confusing here is the data input. Okay, so we've got a whole bunch of individual meshes that are coming through with these, values that we don't really understand yet. And then we have RGB values. So how do we get the RGB values to speak to those meshes? Right? The thing that is kind of your first clue is that the meshes have subgroups, has a group of vertices and a group of faces. That's what that stands for, vertices and faces. So what you see from the other list is that it is what? What's different about this list from that list in terms of how Grasshopper is reading information? And I pretty much just told you to. What?
There's a missing, there's 3 on 1 and 2 on the other.
Close. But what's more significant is the fact that the 2 values that you see in here are actually 30 different values, and they're in parentheses. So that means that this list is broken up into sets of information, essentially. It's a list within a list. And this is just a list. So what we need to get this to speak to that is to graft the information into groups that are communicable. Does that make sense? So let's take a look at what the difference here is. Yes?
What is the command that gave you the bar, the color bar?
The color bar? That's under params input gradient. Okay, so I'm going to drop a panel in. So, well, No, that won't work. Never mind. So let's just take a look at what it looks like. Okay, so the values here right now look like that. Okay. Now, if I okay, so you would think that they'd speak to each other, except this has information built within it, right? Lists within a list. So if I and you see the information right there, if I graphed C, now that information is reading as groups, right? So like sets, lists within a list. And then the other thing I can do similarly on mesh is also graph that so that we're no longer looking at extra information that's, like multiple lists within a list. It's just one list within a list. And then you get this. Which is pretty significant, guys, right? So the question that's probably on your mind is, where would I use this, right? Maybe. I don't know. I'm just throwing that out there. I'm putting words in your mouth. But where you would use this is, this is just kind of throwing out a more pragmatic example rather than academic. But a pragmatic example of where this is valuable is, for instance, I've seen stuff like this used to analyze piles that are driven into the ground for the foundation of a structure. And what they're measuring is how long the pile is to hit bedrock. And so they had certain values that were too long. And so the ones that were too long were red. The ones that were, in a range that wasn't really financially feasible were yellow. And the ones that were financially feasible and practical in order to actually build were green, essentially. So, all of this stuff has practical applications, and it could really be used any way you want to. And this one is purely, location-based. So how far is it from the center point? But you can use stuff like this to do that. Yeah, you can. There are other software packages that do heat gain better, but you can measure, sunlight filtration. That's what I was saying before. Sunlight filtration is a good one. You can analyze area of materials. For instance, like if you wanted to see what the proportion was of metal panel to concrete, something like that. I'm trying to actually, for the next semester of this class, we're going to be looking at the Museum of the Tall Ships, and we're going to develop a definition that will measure your elastic surfaces and boom masts to calculate what your site coverage is, because you won't be allowed to go over 50% of what your site is. And you'll have to, as a part of your design assignment over in design, you'll have to actually show your Grasshopper definition, calculation, your analysis that looks like this to prove it.
For the spring Grasshopper class?
Well, no. So you won't have to worry about it. Basically, for the summer, we're going to start building it in because we won't have time to get it in this class today. But you've got the essence, and if you needed help, I'd help you out with that. Okay, and we'll do some more analysis stuff too. So what other questions do you guys have? Okay, so let's coordinate what's going to happen tomorrow, and I'll see whether or not there's any more in terms of the stuff that we want to do today.